This is a good example of rotating your coordinate system to your advantage. So in order to solve this problem, we're actually looking for the force F from the picture. We're going to have to use Newton's second law for equilibrium. So first thing is let's go ahead and make the coordinate system this way. So F goes right here. T1 is right here. And T2 is going to be right here. And then there is a mass like hanging over right here that's going to pull on T1 and T2, basically giving you the value of the T's. So the first thing we're going to do is write out Newton's second law for our x-axis. This is the x-axis. This is the y-axis. The x-axis Newton's second law is equal to mass times the acceleration in the x-axis. And that's just going to be 0 because it's a stationary leg in the hospital bed, so nothing's moving. At the same time, you can go ahead and say that Newton's second law in the y direction is equal to mass times acceleration in the y direction. And it's also equal to 0. Conventionally, we'll make our coordinate systems positive, going to the right and going up. And since it's tilted, then we'll say up and to the left is positive, and a little bit north of east is positive as well. The point of interest where we talk about the so-called mass is the very center of the product, which is holding all of these forces. So technically it's the leg, but you can also say it's the pulley leg contraption, which we reduce down to a point mass that's in the center of this coordinate system. So that's the mass that we're dealing with. Luckily for us, though, we're not going to actually get around to even needing to analyze the mass. Anyways, moving on, let's go ahead and say the sum of all forces in the x direction is equal to 0. In the x direction, there are 3 forces, 2 positive, 1 negative. So we'll say that a negative F plus positive T cosine 35 degrees plus T2 cosine 35 degrees is equal to 0. Now, why we say it's cosine 35 is because from the picture in the previous screen, these angles are 35 each, 35, 35. So to get the x component of both T1 and T2 separately is to look at the leg of this triangle that borders the 35 degrees. So that's a cosine function there. So getting the T in the x direction is a T times cosine 35. T in the x direction here is T2 cosine 35. Okay, so these right here is really just T2x, and this right here is T1x. Now let's go ahead and isolate F because that's really the point of the problem. F is equal to T1 plus T2 times cosine 35. All right, cool. Now we have a little side quest because we want to find F. We know what cosine 35 is. That's just a calculator problem. But we don't know what these two are. So what we're going to do is a little side quest, which happens to be looking at the y-axis of this problem. So the y-axis, up and to the left is positive, down and to the right is negative. So T1 in the y direction is positive, and T2 in the y direction is negative. T1 in the y direction is going to be T1 sine 35 degrees, and then T2 in the y direction, and there's going to be a minus in front, is T2 sine 35 degrees, and that's both equal to 0. We can go ahead and cancel out sine 35 because it's common value, and dividing 0 by it would just mean that it remains a 0. So we end up getting that T1 is equal to T2. So that helps us a little bit there. The next point we want to look at is that there is a 2.2 kilogram mass hanging off of a pulley that's stationary right here. This is something that you looked at in the problem. So, and this right here, this T1 rope is held up stationary to some sort of ceiling with a pulley on it. So basically, this mass under the influence of gravity is pulling on this rope, and these two ropes are connected right here. So in that case, T1 should equal to T2 as expected, and it should also equal to the weight of this block hanging off of the pulley. So if that's the case, then we can say that T1 is equal to T2. We say it's equal to T, and that's equal to mass of the weight, we'll say, times gravity. That ends up being 2.2 kilograms times 9.8 meters per second squared. And that comes out to be 21.56 newtons. Okay, and that's going to be each tension that you see on this rope here. Now, looking at this, we know what T1 and T2 is. They're both going to be 21.56 newtons, and cosine 35 is now given. So now we have all the pieces we need in order to finally solve the problem. Plugging this into your calculator, we're going to have to multiply 21.56 times 2, multiply then by cosine 35, and that ends up being 35.32 newtons. And if you want to get it into the proper significant figures, then I think 2 being the most proper significant figure given the values in this problem, we say that the force is going to be 35 newtons, and that's the final answer.